Alright, here's a bit of an update on the tractor project, the Oliver 1800 conversion to electric. A few things I've accomplished this winter. Very few, but anyway. So I've developed a lot of electronics in this box here. I'll sort of show you that in a few other pictures. That allows me to have a safety switch here that can turn on the motor and take it out of park just by pushing the button and moving the lever up. There was a whole lot of work I did to decipher the signals coming from the shifter and able to emulate those signals in that microprocessor and get rid of this shifter then. It just shifts into drive automatically by moving the throttle up with the safety switch pushed. I was also able to replace and decipher the signals from the on and off switch. That allowed me to replace that with a more weatherproof switch there. It's actually pretty straightforward, but it also allows me to turn on and off the system through the microprocessor here so that I can turn it on to charge the 12-volt battery. Another piece of circuitry in that microprocessor circuit board that I created is a sensor to sense the voltage on the 12-volt system without having to rely on the CAN bus, giving me those signals, because I need to be able to figure those out with the system off, or mostly off. The microprocessor still running all the time. So what else? So yeah, the shifter, the safety switch, the on and off. Oh, I also as a safety precaution as well, I had to replace the key switch here, or else I could have used the other one, but the other one was sort of crappy. So I am powering the microprocessor here through that on and off switch. This microprocessor forwards all the CAN bus messages from the VCM, which is back there. So it's a man in the middle with those signals. So turning it off actually cuts all of the signals going to any of the components, and everything just shuts down. So that's my safeguard from things running away, because my software running on that microprocessor is controlling the torque and speed of the electric motor. I don't rely on the VCM at all for that. It just controls all the other crap that's in here, which, yeah, is quite a lot of stuff still. So here, let me show you. So right now I have the ability to turn on the system two different ways. I can either push this switch here, which is the thing that'll be mostly used, but for testing purposes, I am allowing just pushing this with the throttle all the way down to turn on the system. That allows me to test that the microprocessor can also turn on the system. So I'll show you that first. So push this. Once it detects the key fob, second time, turns it on. You'll see everything comes up, and it's in park. You can see that. So just to show you, I can move the lever up and down here. Nothing happens except for my desired RPM goes up and down. But if I push the switch in and move it up, you'll see that it goes into drive. And other thing to, so I push it down and not fall off the stool here. You'll see on the other side here, there's the parking pawl motor. I have not yet gotten time to have that engage into the flywheel gears, which is the plan there. So whenever that parking motor turns off or turns, it should block the system and not let it roll. So right now, whenever you push the throttle down and it goes to RPM 0, this will turn into park. I can't really show you that. I need another set of hands, but anyway, that's the idea there is, and you'll hear it if you listen. There's just before it starts spinning, it'll go jink and take the parking out. There's a loud clunk noise, and that's due to the coupler that is coupling into the Nissan motor. I need to order a new one of those that's tighter because it's pretty annoying. It's very loud. I'm worried that it's going to wear the splines on it. Oh, and let me show you the other thing. So this was my Christmas present this year, was a 3D printer. So I've been using it for a lot of things. That box that's the microprocessors in. This knob with the switch there is something I just did. And then this housing for the LCD display is also something that I 3D printed. Yeah, and the display there is functional. Show putting it in. So the RPM on the top with the little indicator showing the desired setting, and the horsepower underneath. I'm not exactly sure that's accurate. I need to do some more testing on that to see if that's correct. But and then you can hear it go into park. But if I push this up without pushing the button, you'll see this little indicator underneath the RPM moving to show where it would go if it was going. Yeah. I think that's about it. That's my update for this time. Oh, let me also demonstrate turning it off. You'll hear the contactors turn off. My display stays on for a while until the CAN bus messages stop reporting, and then it'll go off. But anyway. All right. Thanks. Bye.